compound angles. So one of the good particular uses is, for example, to say, I'm going to start leading with an example. It's actually cos of, let's say, 105 degrees. Now, 105 degrees, you can say, well, Imad, you know, cos 105 degrees is the same as saying cos of 60 plus 45. And the reason for that is 45 and 60 gives me 105 degrees. And so now you can say, well, that's useful because 45 and 60 are both special angles. Now, it does not necessarily mean that these have to be special angles, but what I'm saying is this is just one case in which we can see how useful the compound angle identities are. Now, like I mentioned, we're not going to do any proofs of the compound angle identities right now. We'll do that towards the end of the course. But for now, let's say cos 105. Now, this actually has an identity. The identity is cos of a plus b is equal to cos sine. And then the plus, that we switch to minus. And then that's A, that's B, that's A, that's B. In other words, it's cos A multiplied by cos B minus sine A times sine B. This is the identity for cos of something plus something. Right. Okay, so now I'm going to say, let's use that identity. Let's use that identity and apply to this. Well, in this case, my A is going to be 60 degrees, and my B is going to be 45 degrees. And there we go. That's going to be cos of 60 plus 45 degrees. And then I can say, well, that is just cos multiplied by cos. The plus changes to minus, sine. It's going to be B, that's A, that's B, that's A. There we go. And what is this going to be? This is going to be cos of 60 multiplied by cos of 45 degrees minus sine of 60 degrees multiplied by cos of 45 degrees. Now the truth is, these are special angles. Cos of 60 is a special angle, and it's something you've seen before. If I had to go back and I go look at our special angles, cos of 60 is equal to a half, right? Cos 60 is a half, and cos 45 is actually root 2 over 2. So we can actually just fill that in. Cos 60 is going to be 1 over 2. Cos of 45 is going to be root 2 over 2. Sine of 60 is root 3 over 2, and cos of 45 is root 2 over 2. Now, you can be saying already, there's a mistake. You wrote down the identity wrong. That should be sine. Sorry, I got distracted there by the smell of the muffins inside. But nevertheless, cos, sine, minus. If the original was plus, we use minus, and now I can see that I can just multiply that out, and I get the following. It's going to be root 2 over 4 minus root 6 over 4. That's an important property there. If I have root A multiplied by root B, then the answer is equal to root A times B. And that there is root 6. And if you want to go further, you can say that's root 2 minus root 6 over 4. Of course, this is correct, and so is this. Now, there's an example as to how we can see cos of 105. Let's take another example, and that's the first compound angle identity I want you to consider. Cos A plus B is cos, sine. Okay, so what I'm going to do is I'm going to say, let's do another one. Let's say, Imad, what about sine? Sine of 15 degrees. Now, before I continue with sine, I'll give you the identity for, I've given you the identity for cos. Cos A plus B is cos A, cos B minus sine A, sine B. If I change this to cos A minus B, right, then it's going to become cos A times cos B plus sine A times sine B. And then the minus here refers to the red one, and the plus here refers to when that is going to be minus. So what about sine 15? Well, sine 15 looks tricky. If I told you don't do this do this question without using a calculator, or don't use a calculator, you're going to say, well, Imad, I can do that. That's very, very simple. Let me just take 45 minus 30 degrees, and that gives me 15, right? 15 degrees. And so, well, congratulations, you figured that out. So what can you do? You can say, well, that's going to be sine of 45 minus 15. So let's look at the identity for sine. Sine A minus B is actually equal to sine cos sine multiplied by A, B, and if this is negative, this stays negative. Remember, we only switch it when we deal with cos. So in the particular example that I've got over here, what I want to do now is I'm going to say my A is going to be 45 and my B is going to be 30 degrees. So let's see how I can do that. That's sine of 45 degrees. Let's improve that. Minus 30 degrees. Well, that's just sine cos sine. And the minus stays minus. That's A, that's B. Let's make it specific. It's going to be 45 degrees, 30 degrees, 45 degrees, and 30 degrees. Now these are special angles, and angles you know by now. Sine 45 is root 2 over 2. Root 2 over 2 multiplied by cos of 30, which is root 3 over 2, minus root 2 over 2 multiplied by sine 30, which is a half. And that's going to give me, well, gives me a solution of root 6 over 4 minus root 2 over 4. And of course that simplifies into the following. That says it's root 6 minus root 2 all over 4. Okay, if you wanted to factor this out, you can say, well, that is actually the same as root 2 multiplied into root 3 minus 1 over 4. That's also valid. This is the same as this and this. And there you go. There's two examples of applying compound angle identities. Now, do you know what's a double angle? And that's what I'm going to discuss in the next part.